Hi everyone. Thank you for joining this session. How are we doing? Kicking great. Great weather. Lovely weather. It's just right. Okay, so I'm going to start by painting a scenario. So please imagine along with me. So it's 3 a.m. You're still in your PJs and your phone won't stop ringing. Your on-call engineer finally gets through to you and you see the message. Sorry, I don't know what's up with my voice. So you get a message from your on-call engineer and he says, "We are down. It's the payment processing library." Right? Now, that library was probably written by someone you never met. It's probably managed by someone in some faraway country who you've also never met. And just last month, you had half of your code was generated by AI. And AI has made hallucinations, right, about dependency that doesn't even exist. Now, an attacker has noticed this fictional package, and the attacker actually helped create it. And it's now injected malicious code inside. It may sound like science fiction, but this is the reality of so many organizations nowadays. So, my name is Adaora, Uche. I'm the GRC lead at TG Ingenuity, based in Manchester. Come a long way. And my goal basically is to pull back the curtain on the unintended consequences of collaborative coding as we discuss this title, so many cooks in the code, the security cost of collaboration, and why the biggest threat to our systems might already be sitting inside our code base. So here we have a few statistics. 75% of software supply chains have experienced cyber attacks in the last 12 months. Now, this is a surge of about 180% compared to 2023, according to Verizon's data breach investigations report. Now, what this means is that if we take a look around the room, it means that 3/4 of us, of our organizations, I'm not saying it is, but like 3/4 of our organizations represented here, based on that statistics, have probably been hit. We might be aware of it, we might not be aware of it, but based on that statistics, that's what it means, putting it in context. And now we've added AI to the mess, because 97%, nearly all enterprise developers are using AI coding tools. How many of us have used GitHub Copilot or are using GitHub Copilot? Exactly. Now, there's another interesting statistics here. It says that researchers found that 19.7% of package dependencies suggested by AI models were completely hallucinated. So that's packages that don't exist, but clever attackers are creating and are filling up with nasty surprises for us. So it's something serious. Now, Gartner predicts that by 2025, 45% of organizations will experience supply chain attacks, which would be a threefold increase from 2021. So I can't wait to be in 2026 to see if they will be proven right or wrong. I mean, we've seen the recent attacks on Coop, M&S, and Co. So now, in as much as collaborative coding, has been really helpful in our modern workplace, the way we, build our systems and all of that. But we've also created the largest attack surface in history as a result of that. Now, we're filling it with AI-generated code and we are just flying blind. But let's just go back in time a bit, go through how we got here. Back in the 90s, if you wanted to build software, you probably wrote it yourself, every line of code, every algorithm. You knew everything that was in the library. It was slow, it was painful, it was expensive. But again, you knew everything that was in the library, you knew everything that was in the code. And then the 2000s came with the web revolution, and we had dynamic websites emerging. We're still writing code from scratch using, JavaScript, PHP, and the likes. The mid-2000s, Ruby on Rails came in, Django, and we started building on the shoulders. But we still knew everything in our applications. Yay or nay? Yeah? Kinda. And then microservices in the 2010s came into the mix, and we had modern applications, became distributed systems spanning hundreds of services. And then in the 2020s, it's in the rise of AI-assisted, it's the AI-assisted era, and AI tools now write a significant portion of our codes. So, there's another statistics here that says that 27%, there's been an increase in the usage of AI tools, regulatory usage of AI tools, just by 27% just between 2023 and 2024. So this is something that is on the rise, and it is also increasing our attack surface, like I mentioned earlier on. So this is where we've ended up, and it's quite interesting because now we use a lot of third-party code. 80 to 90% of that third-party code is other people's work. It's like, is like selling sandwich you don't make. You're just applying the napkins. We're using other people's work. A large percentage of that AI-generated code we don't exactly read, do we? I can see the smiles. Yeah. So, we also have dependencies that have dependencies that have dependencies, and, it's really complicated and tedious right now. And all of this work is done by people we've never met and we probably will never meet. That is the, current situation on ground. Interesting, but also causes room for concern and caution, even as we deploy these tools. So, if you take a look at this diagram here, okay, this is what this is what, installing one simple Node.js in your library looks like. It's like an explosion. So that's you trusting someone with your business. Every single one you use there is trusting somebody with your business. Now the thing is, you're not just trusting someone with your business. It's like giving someone the key to your house, and the person gives it to another person, who gives it to another person, who gives it to another person. Now, in as much as this helps us, scale, build faster, faster deliveries, scale, bigger than ever before, but it is very uncomfortable because every code you did not write, whether from a human being or from our new AI overlords, is a line of code that you don't control. And that's where the story gets interesting. I'm just going to touch on traditional threat models and the modern threat models. So, traditional threat models, the attacker is thinking of the perimeter, the firewalls, intrusion detection, trying to bypass all of that, the network security. But with the way things are now, it's different. Why? Because it's already baked in the code that you deploy. So think back to the fall of Troy, which is quite similar to what this is. AI is like a gift, that giant gift that is very, very fresh, never been seen before. But inside, just like when it was offered to the king of Troy, inside that Trojan horse were, the attackers waiting to take down the city. So it's similar to what we have now. We've got this beautiful, beautiful tool that can do so much for us, but inside the code base, right, these attackers have baked, malicious code inside. So, let's get some case studies. In 2020, December 2020, FireEye announced the discovery of a highly sophisticated cyber intrusion that leveraged a commercial software application made by SolarWinds. So, it was discovered that the attackers first gained entry in 2019. September 2019, this was only discovered in December 2020. So they had 14 months of unfettered access in the system. So how did it work? They compromised the Wayne's build system, and by March 2020, they began to plant remote access to malware into their updates, thereby Trojaning them. And 18,000 customers downloaded this compromised code between March and June 2020. And the funny thing is that these malicious codes had legit digital signatures. It looked completely trustworthy, and they had access to US Department of Homeland Security, they gained access to Department of Energy, Department of Commerce. They were able to target such high-profile organizations. So think of it like instead of trying to break into individual homes, poisoning the water supply to those homes. I mean, one compromise, thousands or millions of victims. That's what we are facing now. Another example is one from 2016. A programmer took down the LeftPad package he had published to NPM. So there were thousands of software projects, including Facebook, Spotify, PayPal, Netflix, that used LeftPad as a dependency. So what he did was they were unable to build or install after that attack. So this caused widespread disruption as technology corporations, small and large, used LeftPad in their software.